Hello and welcome to the video. This video is part of a new series that I'm creating at the moment called Common RC Questions Answered, and I'll put a link here into the playlist because there's lots of other videos that I'm going to be creating like this, putting them all together. So if you're new to radio control, or it's a hobby that you're interested in getting involved in and you're trying to demystify some of the very complicated technology and terminology that gets used all the time in the other videos knocking around in places like YouTube, then this is the place to be. If you're interested in finding out a little bit more about radio control, then I also have a series of other playlists on the channel that's probably worthwhile having a look at too. There's the Introduction to Remote Control series that's also on the channel that has lots of videos, some of which I'll be referring to in the video that you're about to watch. And there's also lots of other channels designed for newer pilots, and they're typically called Introduction to or for beginners. So for example, there are Quadcopter Building for Beginners series and Wing Building for Beginners series 2. But let's get down to the topic for this video. So first of all, let's talk about how you can fly your model for longer. Now obviously the limiting factor on the model is how much energy is in the battery. Once the battery is flat, then you've got to land. So the trick is, how do you make that battery last for longer than you're currently getting? And obviously the first thing that people think of is, well, all I'll do is I'll just stick a bigger battery into the model. And that might be okay if you're looking at a fixed wing model. Fixed wing models are probably more tolerant of having bigger batteries inside. Some quadcopters though, if you put a larger battery on, you will dramatically change the way that they fly. You might have to change the throttle curve, and you might also have to change the PID settings as well, having a big heavy battery strapped underneath. The other thing that you have to remember, of course, is that a bigger battery is going to weigh more too. So you don't get all of that additional capacity as extra flight time. So if, for example, you were using a 1000 mAh battery on your model and you replace that with a 2000 mAh battery on your model, you are not going to get twice the flight time, because a lot of that additional energy is going to be used by the model to stay in the air to counteract the heavier weight of the battery. So in that situation, you might get 1.6 times the original flight time, but you'll pay a penalty for having the heavier battery. Again, in a fixed wing, that penalty is much less, but that's due to the fact that the lift is coming from the wings, not from the rotating propellers. The other thing you can look at as well is have a look at how your ESCs and motors are rated on your model. Now the motors will pull a particular amount of current for a particular prop size and produce particular amounts of thrust. And it might be that on your particular model, if you swap from 3S to 4S or maybe 4S to 5S, you might find for the same amount of thrust for the way that you're flying the model, there will be less amperage. So check that and have a look at that as well, because it might be that that's a slightly easier way to swap out a battery and give a little bit more power to your model without adding too much more weight to get that slightly longer flight time. If you're looking at a fixed wing, then the thing I would say is have a look at lithium ion packs. We've looked at lithium ion packs previously on the channel, and they are very low amperage capacity. Those are those kind of 18650 cells that are used all over the place now in the hobby and also in things like vaping machines. They have a huge capacity for energy, but they don't release it very quickly. But in something like a fixed wings don't pull massive currents like quadcopters do. You can get away with it, and you can get hours of flight time in a fixed wing that can also support longer range too. My big tip with this is, if you are really looking for longer flight times, then the best thing you can do is actually look at how big the props are that your model will support. The whole point of these 5 and 6 inch props that we end up using in our quadcopters are due to the fact that everyone wants small racing frames, but they are inherently much less efficient than larger propellers. On full-size aircraft, designers will try and fit the maximum size prop that they possibly can safely, and that's because the bigger the prop, the more efficient it is. So if you look at some of the earlier videos that I've done, where I actually compared a low kV motor with a large prop compared to a high kV motor with a small prop, you can get the same amount of thrust out of that setup with much, much lower power being pulled from the battery. So if you're looking for longer flight times, and you can, then I would potentially swap the motors out for lower kV ones, put bigger props on those motors, and you'll get the same amount of thrust as with the smaller setup. Again, I'll refer you that to a video. I'll put a link in the description if you want to go and have a look. I did a practical demonstration of how that actually works, but it makes a massive difference. And that's why these really small quadcopters with little 2-inch blades don't fly very long at all. Although they can produce the thrust, they do it very inefficiently. They burn through the energy in the battery very, very quickly indeed. So the other point is about throttle management. Flying slower will use an awful lot less power and allow you to stay in the air longer. If you fly it like you stole it, the battery isn't going to last as well as if you're just doing gentle acrobatic flying or just even flying around, just having a look. And also remember that in a fixed wings will float. They will soar as well when you kind of turn the power off. So occasionally, if you're using a fixed wing model and you're at height and you have the luxury of a nice calm day, then absolutely drop the throttle to very low and you can poodle around and reduce the height over time, and being smart with your throttle can extend the flight time significantly. So now that we've talked about how you fly for longer, the other question I got is how can you fly further? Now the first thing and the caveat we need to put in here is do be careful of your local laws for beyond line of sight flying, BLOS. In lots and lots of places it is illegal, so trying to fly beyond your line of sight is going to be a naughty thing to do. And also be careful of your maximum height. Fly legally. I'll put a link in the description for us UK flyers that explains the rules for radio controlled aircraft. But let's talk about the two ways for those of you that can fly further that you can extend the range on both the radio and also FPV if you're doing it that way too. Increasing the radio range is pretty standard stuff. We've talked an awful lot already on the channel about increasing radio range, and there's a full series on the TBS Crossfire. Now the TBS Crossfire is just one of a number of long range systems that you can add to your radio to take the range up from a typical 1.5 kilometers range in a 2.4 gig radio up to tens of kilometers of range. These systems use a much lower frequency, and that allows the signal to propagate a lot further with the same amount of transmission power. Special antennas on your radio that are more directional and more sensitive can also help too. But for long range, the best bet is to go and invest in a long range radio module and a long range receiver for your model, and that will give you much longer ranges than the typical 1.5K that you're going to get out of a 2.4 gig radio. The other side of this equation is how do you increase your FPV range, and typically legal 5.8 gigahertz FPV is measured in hundreds of meters, 200, 300, 400 meters, depending on how sensitive your antennas are. Now, directional antennas can help with this. Again, there's a video in the introduction to FPV that talks all about the different antenna types, but most antennas that you get these days, the circular polarized ones, have wonderful reception all the way around, so you can fly behind you, left and right of you, and still get great reception. And other ones like patch and helical antennas have a much narrower cone of reception, so you'll get a little bit of reception around you, but if you try and fly in a big circle with you at the center, it'll only catch the bit in front of you. And by using both of those in a diversity setup, that will give you the best of both worlds. It'll give you a nice 300-400 meter range around you, and then using a longer range antenna, you'll be able to fly further away in one particular direction. Now, using more sensitive receivers and better antennas, or more sensitive directional antennas, will obviously improve that more and more. And I've started to see a couple of tri-versity setups coming around. And you also, if you remember, you have those systems from people like Hobby King that were called the Overlord. And that is lots of directional antennas arranged in an array, and that gives you really good range in all directions. Or there was something called the Half Overlord that kind of just did it in kind of a 180-degree arc. The other way, of course, that you can increase range, if it's legal to do so, is increase the power on your video transmitter. Lots of places the legal limit is 25 milliwatts, but many video transmitters allow you to increase that to 200, up to 600, and sometimes even 1 watt. And increasing the power will give you much farther range, but again, you have to be careful of your local laws, because in a lot of places that isn't a legal thing to be able to do. For really long FPV, you have to abandon 5.8 gigahertz completely and have a look at one of the lower frequencies. So if, for example, you decided to use your radio and the radio is using a much lower frequency, so maybe you're using a crossfire system, that then means that you're not using the 2.4 gigahertz band for radio control. You can use the 2.4 gigahertz band for FPV instead. And that will give you much longer range. And for really long range, you can use the 1.3 gigahertz band, but that has a very small number of channels in there that you can actually use. And the problem is as you reduce the frequency that you're using for FPV, you have to increase the size of the antennas. So the antennas that you see listed on site to support 2.4 and 1.3 gigahertz FPV are physically a lot larger than the antennas that you're probably used to seeing for legal 5.8 gigahertz. And the last comment I'll make here is if you are interested in pushing the envelope in terms of line of sight, or you are in a place where it's legal to go beyond line of sight and you're going to use something like a TBS Crossfire or an FrSky R9M, you may be going to use a 2.4 gigahertz FPV system with lots of power in the video transmitter on the model, then do consider including some kind of flight controller in that model as well. Something like the Eagle Tree Vector that we've looked at on the channel, something like the Pixhook system, or something like iNav. And that way, if there is a problem with the connection, or there is an issue and failsafe happens, or the system detects that the battery is getting low, then it can initiate a return to home and fly back to you safely. In my opinion, if you are going to be flying any kind of distance at all, then it's definitely worthwhile investing a couple of £100 in a really good flight controller system and popping it in your model and making sure that all that fail-safe stuff works great. And also by having some kind of flight controller in the model on that FPV image, you're going to have information about the distance, range, direction to home, battery status, amp draw, and all that goodness, so you can monitor when it's time to turn back and head for home. If you found that video useful or like the content, then please hit the like and subscribe button down below. If you want to go the extra step, you can become a Patreon of the Painless 360 channel and help provide support for what I do here. All the videos created here are put into playlists, so if you're interested in a particular topic, have a look at the playlist, and they all are organised in there to make them easier to use. If you're not sure if there's a video for your particular problem or topic you want to know more about, then add Painless 360 to the Google search term that you're interested in, and that should find the video, article or content about the particular thing that you're interested in having a look at.